Open your Python script editor of choice. I like to use Spyder. So as an example, all these examples actually do come from Spyder version 3.12. And again, this is through Anaconda. In this continuation of our S3 tutorial, you'll use Python to create a connection and create a new bucket. Of course, once you're successfully connected to your bucket, you can download files and perform analysis, data cleaning, etc. Likewise, data can be uploaded via Python. So to begin your Python script, import the Boto3 library and simply create two variables. Disclaimer, and please excuse me if I'm pronouncing this incorrectly, but I'm calling it Boto3. From the Boto.s3 connection, import s3 connection. The AWS underscore access underscore key underscore ID equals, and then in the quotations, paste your key ID here. This is where you're actually going to get that ID that we've gotten in previous slides, and you're going to put that right here. The next step will be to create the AWS underscore secret underscore access underscore key. And in those quotations, you're going to paste your secret access key again here that we got in previous slides. So we will create a connection variables like so, where we have con equals the S3 connection. And then within the parentheses, we'll actually have both of those two arguments. So the AWS access key ID and the AWS secret access key variables that we created before. The S3 connection function takes two arguments and your two previously created access keys. Next, we will create a new bucket. This function in Boto3 is called con.create underscore bucket. We will name our new bucket MSDS7330 version 2 or V2. So the bucket equals con.create underscore bucket, and then within the actual parentheses, we'll have single quotation of our new bucket that we've created, the MSDS7330 V2. As an additional step, you can access the bucket to upload or download data. The appropriate function in Boto3 is con.get underscore bucket. As a reminder, in our last step, we named the bucket MSDS7330 V2. The MSDS7330 bucket equals con.connect underscore bucket for this holding place. And your Python script should look something like this. I know this may be a bit repetitive, but just to make sure we cover all bases, we will go through it pretty detailed. We begin by setting up the connection. Remember to define your key ID and secret key variables. So if you can look in the script below, we can actually see how that's going to look from the previous slides of what the actual Python script will be. If your Python code has no errors, you can check in the AWS console and see the newly created bucket. So once we create this bucket and we access this actual bucket using the syntax below, when you go to the Amazon S3, you will be able to see that create a bucket, and there should be the V2, which you can see here in the below screen. Before we explore the final aspects of the S3 tutorial, let's look at what could go wrong in your Python access steps. Now, again, this isn't exhausted, but this is some of the key ones I think that we found within the possibilities of what could go wrong. But recall the point we made earlier about bucket names being unique. Let's create a bucket with a generic name and see what happens. So let's follow the same procedure as before. This time, however, let's change the bucket name to my bucket instead of MSDSV2. I'll give you some time to actually look through all of this, but when we have that bucket equals con.create equal underscore or create underscore bucket, my bucket, you can see that when we go down, there's a conflict. If your bucket name is not unique, then your error message will let you know. The requested bucket name is not available. The bucket namespace is shared by all users of the system. Please select a different name and try again. This is the common mistake when creating a bucket in Python. So again, don't get too frustrated if you get this error. This is a common one. So again, check your bucket name and maybe you have to change it up a bit. So far, we've gone over what AWS is and how it evolved. We walked through S3 bucket creation and uploading data both from AWS console as well as through Python. So what now? We have data. What next? As we mentioned, S3 is the foundation of AWS. The data that we upload can be used in almost all the other AWS applications. Let's explore one. This is just a quick example of how the S3 bucket can aid us in completing analysis. We'll use AWS machine learning applications to understand if we can classify the data we uploaded. So in this section, we will not go into a deep dive discussion of how classification algorithms work, but our goal is for you to really understand that S3 is not just a place to drop data, and reference only when needed. Instead, S3 is a step one in making your analytic solutions scalable to your organization or in your organization. AWS enables us to make the transition from data storage to prediction very easy. So let's go back to the AWS console, and instead of storage, navigate to the artificial intelligence section. It should look like this. So again, we go back to the select machine learning, and in the artificial intelligence, you have Lex, Amazon Polly, recognition, and machine learning.